As you can see, we have a fan with normal IDE power type. Looks like this one's supposed to have a little LED light. It's a computer fan. This looks like it's the secondary power for some kind of blue light. Total cost me was $18, $18.48. Okay, moving on. Yep. The reason why I put it in envelopes is because of that. Wow. I wanted it easy to extract. Ow. Okay. So, next step, one second. Let me get my scissors. Okay. Next step, this. Do not put this stuff near, don't put that near a LED monitor or anything. I don't need. I'll put this on the ground for now. So I don't need. I'll put it on for now. Okay. Let's go snip it about it. Gotcha. Okay. Okay. I have no idea if this is going to work. Can't return that now. Okay. Oh wait. Who's that? That's me. Cool. You get to see me do my stuff for a second. Pull this out. I might actually. This is wire. I might keep that first. Okay. Wow, look at that. It's ripping the envelope. It's still in there. Oh, damn it. I extracted this from the internal, two internal hard drives. So do you see it? See it? Extracted these 4 pieces from 2 internal hard drives. I think I'm supposed to have that. Yeah, I'm supposed to have this. Okay. There we go. 1. Let's just keep going. Next one. Looks like this is for the LED lights. I don't want this. All I'm caring about is the motor. Okay, so I'm going to cut that off. It looks like there's a stopper in here. I'm going to try and pull that out. Looks like there's a circuit board in here too. I got 2. This isn't the right orientation, I think. I'm going to keep going. I really shouldn't have those magnets this close to this phone, too. There. That's good. That's better. The envelopes is saving me a lot of time. Oh my gosh. Prying these off would have been horrible. Oh, they really want to stick together. There we go. Sheesh Louise. Okay, 1, 2, 3, 4. I'm trying to have it look like the video as best as possible. Basically, some guy was able to get the thing to spin without electricity. So that's all I'm trying to see if I could do. Okay. This one's... Maybe... That's interesting how it goes like that. Oh, damn. Okay. Wow. Wait a minute. That just... Okay. Man, how am I going to get these apart now? Shoot. Okay, good. No, no. Wow. Huh? No, did you just see that? Hold on. Look at that. I barely... Okay, there definitely is something happening with the magnetic field here. Wow. Oh, okay. I'm going to double check this 1 second. Neodymium Perpetual Motion motor experiment reproduction 1A. Got all the magnets in here. See them. I like that this is transparent so you can see that I got the magnets in somewhat as the correct spots. Dropping in the fan top. Although it seems that the magnets are giving it a little bit of an extra tug. It's definitely not moving on its own. It's got slightly more tug than when it did before. If I move another neodymium magnet type thing around here, you see it reacts to it. In all likelihood, that's more of a result of the neodymium inside this rotor stator, little motor here, trying to push and pull away from the magnetic field of this. It's not necessarily, in my opinion, creating a perpetual motion type of thing. I mean, look at there, it's not even reacting. This in no way means that this is not possible. It just seems that for, hobbyists or, non-big budget researchers or people without extreme precision equipment, because I mean, look at me. It's hard to get it to be flat. This thing, it's hard to get it perfect. I just used some old hard drives that I wasn't going to use anyway. See, it's kind of, I mean, we got things reacting, but it's supposed to be literally spinning on, spinning, not maybe spinning. So, still definitely doing the research on the radiometer, but as for magnetic perpetual motion in a flat fan situation, this one doesn't seem to match up with what I've been seeing in other videos on YouTube. So conclusions are more precision research needs to be done to see if the spinning videos on the YouTube are a hoax or not, because it could definitely be that just like my stuff isn't precise enough, which I completely I accept that, I concede that. That is perfectly okay. But the I mean, in terms of let's just talk neodymium for a second, okay? What is neodymium? It's actually a powder encased in nickel plating, okay? It's very difficult to process. It's not a rare earth metal in the sense that it's hard to find. It's just that it's very rare earth metal in the sense that it is hard to find in consolidated and pure quantities. It's usually part of an ore of something else. That's why you always hear that, the costs of rare earth magnets and those type of things are of particular interest in the world market. The reason why is because that neodymium is expensive. I mean, look how it's sticking to this. It's, it's expensive. It's very expensive to extract from all the mountainous regions of China, which is in its most abundance. Now, the reason why it's used so much in hard drives and other commercial and industrial applications is that when it's refined, the crystalline structure of neodymium tends to be very uniform, and its specific, uniformity, you can look into more into like its axial crystalline structure. That gets deep dive into chemistry that I'm not even, knowledgeable enough to talk about, but it's structure and density and composition which makes it such an interesting metal, and why it is so magnetic. Pretty cool, right? That is why it's been of such interest in the hobbyist community. It's like, okay, can we use this for something big? But in all major industrial applications, there's always something powering it. It's not perpetual motion from the magnet itself, but either water from a dam is spinning, and then the magnet's spinning in conjunction with a magnetic flux is captured by the copper wire. It's the flux being captured that creates the Faraday principle of the electricity. That's why more research needs to be done, because I have seen a perpetual motion device made where there's just one magnet and all there is a long solenoid, which is basically coiled copper wire. That one, that's why I'm not saying that this is done, but it just, in terms of energy output, the amount of expense required to extract neodymium would probably outweigh the energy output of any solely neodymium-based energy production per device. And then also, another factor when talking about magnets is that they tend to be a little bit, like, I'm not sure. Well, I'm going to talk about that part later, but yeah, they're very interesting stuff. I definitely encourage people to do their own research. But as for perpetual motion application, not seeing it yet. But that doesn't mean we're just going to stop the radiometer research. So thanks for watching, and I'm going to also add some related links in the end card.